Hi guys, for this video, it's gonna be chapter 5, part 1. Let's start with the first one. Sampling distribution. The concept is the sampling distribution of a sample statistic calculated from a sample of n. Measurements is the probability distribution of the statistic. There's a probability distribution for the statistics. We have to know about parameter and statistic. Parameter is a numerical descriptive measure of a population. The statistic is a numerical descriptive measure of the sample. So, there's a few symbols that you have to remember about the parameter and statistic. First, mean. The parameter is mu. And the mean for statistic is a x bar. For the median, the parameter is right like this. And for the statistic, we can write small m. The next one is a variance. For the parameter, the variance is the sigma square. And for statistic is x square. And then standard deviation. The standard deviation is the square root of the variance. So it's gonna be sigma for parameter and s for statistic. The next one is binomial proportion. It's a probability of the event that's gonna happen. For example, flip the coin, we're gonna have head and tails. So head is 50%, tail is 50%. So the proportion of head is 0.5. And the proportion of toe is 0.5 also. And also, binomial is a distribution that we have only two alternatives. So, the proportion for parameter is small p. And for the statistic, we're gonna be p hat. Like this. You can write p and put a hat above it. The next part is unbiasedness. The point estimator is a rule or a formula that tells us how to use the sample data to calculate a single number that can be used as an estimate of the population parameter. And then unbiased and biased estimate. For unbiased estimate, if the sampling distribution of a sample statistic has a mean equal to the mean of the parameter, the statistic is said to be an unbiased estimate of the parameter. And then if the mean of sampling distribution is not equal to the parameter, the statistic is said to be a biased estimate of the parameter. Biased, unbiased. For example, we have the population in the range of x equal to -5, 0, and 5. And the probability distribution is 1 over 9, 6 over 9, and 2 over 9. This one is for parameter population. And for the sample distribution, we have x equal to the range over here, same range, because it's for the population. But we gotta add some more, like negative 3.33, negative 1.67, 0, 1.67, 3.33, and then 5. And the probability distribution is equal to 1 over 729, 18 over 729, 114 over 729, 288 over 729, 288 over 729, and then 22 over 729, and 8 over 729. This one is for a sample. When we find the mean for this one, we have to use sigma of x bar times p of x. So for the population, will be equal to negative 5 times 1 over 9 plus 0 times 6 over 9 plus 5 times 2 over 9 from x times p of x, and sum it together. This will equal to 5 over 9 or 6.556. This is for the mean of population. And then for the sample, we will use same strategy. I'm gonna use x times p of x and then sum it all together. So it's gonna be negative 5 times 1 over 729 plus negative 3.33 times 18 over 729, and so on until we reach 5 times 8 divided by 729. This, if you use a calculator, it will equal to 0.556. So for this example, we got the mean of population and the mean for the sample. The answer is equal. So this one is unbiased estimator of population mean. Yeah, that's it for today. I will see you in the next video.